So, can anybody think of any applications of where you might see quadratics? Some of you guys do things that are quadratic in nature. Did you know that? Is anybody in any sports? Anybody in basketball? Because if you're in basketball and you're shooting the basketball, that's making a parabola, okay? Or if you're in baseball, again, if you're throwing the ball, you know, again, that's having a particular part of a quadratic, and things like that. Or I know sometimes, has anybody ever done some fun stuff back in middle school with Mr. Daly involving rockets or anything cool?
Oh.
No? Yes? Yeah. So, you know, what comes up must come down. That's quadratics. So lots of things in life are quadratics. We just don't normally think about that. Okay. So again, where do we use quadratics? So this is just kind of, again, showing you some applications. So if you don't like quadratics, you can blame this guy. Okay? Obviously, you can't do anything to him. Why?
He's long gone.
He's long gone. So does anybody know anything about Sir Isaac Newton? Gravity? Yes. Right. And so we really started getting more into quadratics with, you know, Newton's work with dealing with gravity and the laws of motion. And so that's really what kind of goes in that kind of stuff. And again, the reason we're going to be using it is because we use, like, we want to figure things out, like, when is an object going to hit the ground? Okay? Or what's the highest height something would be? If I shoot a rocket in the air, what is it going to be its highest height? Or things like that. Some careers that, again, use quadratics, again, could be engineering, welding, fabrication. If you're going into being just more of a science kind of person, that would be kind of that. So again, I kind of put a soccer ball, again, because if you're kicking it, that's kind of making that trajectory. Again, rocket being launched, when is it going to hit the ground? But we see quadratics everywhere. I mean, you could, you know, say you go to the bubbler or the water fountain, whatever you want to call it, and say you press the button, what happens?
It goes on my face.
Yeah, the water is going to come out at it's going to come out at a curved angle. That's a parabola. So lots of cool things. So when you look at fountains, that's what sometimes I look at. I'm like, ooh, cool, that's a fountain. Ooh, that's a parabola. So like you say during the summer, you go to the splash pad. I know you guys are probably too old for the splash pad.
Oh, no.
But, and parabola. So anyways. So again, lots of different things that you can do and you can look at. So you could, like, if that was a particular graph of like a ball, we could just say, okay, what's the tallest height? You know, when is it going to hit the ground? Things like that. So that's kind of the purpose. Okay, so we're going to do some story problems together and just kind of get you going with some of these, and then some of them you're going to do in practice, and then we'll kind of meet back on Monday about what you guys have questions on, and we're good to go. Okay. So here we have a park. It's going to be a playground. The playground is planned to be 30 meters by 20 meters. But then they decided they wanted to revise that, and they wanted to double the area of the playground by adding strips of the same width to each side. And then we wanted to make sure that the final area makes a rectangle. And so we're supposed to find the width of the strips and the dimensions of the new playground and figure that out. Okay, and so this is going to be involving a little bit of quadratics. Okay, so what could we do with this? Like, maybe we should probably know what this is, right? The old field or the old playground, like, ideas. So how would we know what to do with that? Because remember, we're doing some area, right? Could I find the area of the original plan? Sure. What would I do? Yeah, 30 times 20. So 30 times 20, which is 600, right? Meters squared. Okay, so we know that. So we have that piece. So let's think about that. If we're going to double this in size, then what are we going to be talking about when it comes to area? So, because that's kind of why we're doing that part, because we need to kind of think about how much area do we really need. So what would be a good answer to that? Because they say if they're going to double it, what would it be? Nobody knows. It's Friday. Thank you. It's 1200. So, all right. So our new one is going to be double that, which is going to be 1200 square meters. Okay. but we don't know what x is. So we're going to increase each side by the same amount, but we don't know what it is. And then we need to figure out from there what those new dimensions would be. So let's think about that. So how would I find how long this side is? Because we're going to calculate some area, but it's just going to be using some of our algebra skills. So what would be the width of my new playground? So 20 plus x, so that's my new width. Remember, length times width. And then what would be my new length? So 30 plus x. And what should my new length times width equal? 1200. Okay, everybody with me so far? Okay, so now when we're looking at this, what do we know that we could do? What could we do with that? It's already factored. Let's unfactor that. So remember we called that double distributive, FOIL. You could call it hashtag if you had Mr. Tesh and you like doing the boxes. So that's what we're going to do. So we're going to first do 20 times 30. So what would that be? 600. Okay, plus 20 times x. And then we're going to do x times 30. And then we're going to do x times x. Okay. What do you think we could do with this equation? Yeah, put together some like terms. And we probably could even write it pretty so it looks nicer. Like we can put what that polynomial, we can put that in descending format. So what that means is what probably should go first instead of the 600? X squared. So most of you guys like it written that way. So we have x squared. What can I do with the 20 and the 30x? Add them, so that makes 50x plus 600 equals 1200. So now we're back to a quadratic. So now what we have to think about is, okay, out of our styles, what style do we want to learn or do? So remember, what was the first strategy that we learned how to solve quadratics? First strategy. Yes, factor. So we could factor it. Okay, what would be another option? Complete the square. What would be another option? Quadratic formula. What would you like to do? So I'm going to leave that open for you guys to figure out. Which one should we do? You want to do quadratic? Okay. But to do the quadratic, what are we going to need? It doesn't equal 0. So what am I going to do? Yeah, so we're going to subtract the 1200 if that's okay. So now I'm going to have x squared plus 50x minus 600 equals 0. I was trying to see if I could factor it in my head. So I don't know why I don't want to extend it. There we go. Okay. All right. So now that we have that, let's do the quadratic. So we have A being 1, B being 50, C being negative 600. So what part of the quadratic you guys want to do first? You want to do the discriminant?
Yeah.
That's what that's called again, that b squared, and then missing that opportunity to meet 4 awesome chicks. So, or if you're a girl, you could think of 4 awesome cowboys, if you have a cowboy thing. I'm just saying. Okay, so we're going to have 50 squared minus 4 times 1 times negative 600. By the way, that first one is factorable. By the way, if you did want to factor it, you could. So, all right, so anybody know 50 squared? That's 2500. And then these two minuses will make a plus. So what do you think we're going to get there? 2400 which is together going to make 4,900. Now don't forget, we're going to have a square root on that. So now let's put the rest of the quadratic in. So we need negative b. So that'll be negative 50. What would go in the denominator? 2, just because 2 times 1, 2. So we're going to have negative 50 plus or minus, anybody know anything about 4,900? That's 7? 7D, yeah. And then over 2. So let's get our two answers, okay? And so we're going to have first negative 50 plus 70, which would be what? 20. And then we're going to have 20 divided by 2, 10. Okay, then let's do the other one. So negative 50 minus 70, which is negative 120, and then divide that by 2. Now, but we're talking about a rectangle, which means we're going back to some geometry. So what do you remember about geometry and distance and things like that? We can't have a negative. So this, we're going to have to discard this because we can't have a side be negative 60. So therefore, it means they must have increased each side by how much? 10 meters. So therefore, the question was asking, what's going to be the dimensions? I believe it's asking for what are the dimensions of the new playground. So the new dimensions are just going to be 10 more on each side. So x is really going to be 10, and then my new playground is going to be 40 by 30. Wait, no, not feet, meters. And we're done. So again, an application of some quadratics. We'll figure things out. Okay. All right, let's see how many of these I have on here that we can kind of maybe pick and choose if we want. Okay, this one we've got distance. Oh, that's it. Well, then that's the one we're doing. All right, so the second one is talking more about distance, and a lot of these are going to involve distance. So when you look at some of the story problems, it's going to be a lot about traveling, and then I thought to put some car things in there because I know a lot of you guys are either in the process of, you know, getting your driver's license or have your driver's license and things like that. So that's why I did that particular one. So anyways, and then there's a cool problem involving planets because I like astronomy kind of too. So then I put that in there. So I'm multi-rounded. I like lots of different things. So, all right. So here we have the distance of an object. It travels can be computed with the initial speed. And again, with the constant rate of acceleration. And then so it says the formula that relates these factors is 1/2 a t squared plus b I t. And so that's what we're going to kind of do. ACT likes to do these things too. They give you some weird, wacky formula, and then they want you to be able to plug stuff into the formula and then work it out. And so we're trying to figure out if the car has initial speed of 20 meters per second and constantly accelerating 2 meters per second to determine how much time it takes to travel 145 meters. So that's what we're doing. So, okay. So we're going to write this particular equation. Okay. And so we kind of have to look at what some of these variables mean. So like here it says an initial speed. So I got to figure out, well, where does that get plugged in here? So then I probably would read the problem a little bit more and say, oh, okay, that is VI. So that means in this spot, I'm going to put a 20. And this is going to be T because we don't know the time. Okay. All right, so we have that. Okay. A is my constant acceleration. So does it tell me a constant acceleration? It's 2. So now I know I'm going to have 1/2 times 2. And again, I don't know the time, t squared. Now, for here, s is actually going to be the distance of the object. So actually, I do know that. So they want us to travel 145 meters. So what I kind of did was take this initial formula and plug things in. And so I do try to help you and give you the formulas to kind of work with that and so forth, to kind of give you a general gist of what to do. So like this formula, you're also going to use that same formula also in number 2, like in number 3, you're going to use the same formula in number 2. So that will kind of be the same. And then 4, you're going to use the same formula as well. And then 5, I kind of give you a different one, but it's very similar except it's involving gravity. So, all right. So let's clean this up a little. So we have 145 equals, let's multiply these two. So what do we get? 1. So we'll have t squared plus 20t. All right. It's a quadratic. What do you want to do? So remember, we could factor. We could do the quadratic. We could do complete the square. What do we want to do? We could probably try to factor it. I don't know if it comes out nice or not. So, I don't know. Otherwise, we could complete the square. Should we complete the square just for fun? Do something different other than the quadratic? So, but I like it the way it is for complete the square. I do not need to make it equal 0 to do that. The only thing I'm going to do is, do you mind if I just move this over and flip sides? Is everybody okay with me doing that? You know what property that is? Just to go back to some of your properties. Close, but not. Symmetric. That's symmetric when you flip it over the equal signs. All right, so how do I complete the square again? I'm glad that we're doing that. Take half of 20, and that's 10, and then square it. So 10 squared is 100. Okay, all right, I added 100. Yep, do it to the other side. So, okay, I should be able to factor this now. So you guys told me what number did I square to make the 100? 10. And then why is there a plus sign here? So why did I do that? Where did we get that sign from? The first sign. And then this is going to be 245. Yay? Okay. Now what? Okay, square root. I think we're going to probably have to do something with this 245, though. Don't you think? So should we find a perfect square, or do you want me to do the tree? What would you like? All right, you find the perfect square. I'm going to do the tree. So I'm kind of doing the tree here. Okay, what do I got a pair of? Sevens. So therefore, if I reduce this, we're going to have, hello. So we are going to have plus or minus 7 roots 5. And then what do we do next? Yeah, so we have to subtract the 10 there. So we're going to have negative 10 plus or minus 7 root 5. The bad thing is, because this is a story problem, is that going to mean anything to us? So do I know how much time that is? No. So we might need to use a calculator to figure out what that is. And so we can do that. So let me quick grab my calculator. You got to remember the answers for me, because otherwise I'm going to forget, and that's never a good thing. So. All right, now, what happens if we have what if we have like an issue that happened in the last problem? Like, what if I have positive time and negative time? So we might have to cross that bridge, you know? So, okay, so what was one of my answers again? We had what, 10? Wasn't it 10? No, yes, 10. Okay, plot was negative 10? Okay. All right, so negative 10. First, let's do plus. Okay, and then it was what, 7 root 5? Okay, so 7, and then square root 5. Okay, enter. Okay, so 5.65 seconds for time. Okay, or and then 7 square root of 5. Or negative 25.6 seconds. So, which makes sense? Okay, why does that not make sense? We can't have negative time? We're not Back to the Future? No? Does anybody know of that movie? So at least I don't feel so old? Okay, good. Wonderful. So yes, so that would be my answer. So how many seconds does it take for the vehicle to go 145 meters? It would take if you want to round, you could say 5.7, or you could just say 5.65, and then that would be seconds, because that's what the time unit is on that. So 5.65 seconds, which isn't that long actually. I mean, that's why I got all the cars. Like sometimes you listen in those car ads, it can go from 0 to 60 in this many seconds. Because if you want to go really fast, So, so anyway, so that's kind of what you're doing with your story problems. So, you think you'll be okay? Good. Try. Report back. And that's what we got.